Alright, welcome back ladies and gentlemen. Now we're talking in section 1.7, transformation of functions, and you can see right there it says we're going to sketch graphs and write equations for functions based on various transformations. Alright, and got some directions here for the first examples, which are actually going to be the kind of second chunk of your homework. I'll explain that as we get to it, but here we go. For the first two examples, we're going to identify the parent function f. Really, we could say f of x right there, but sometimes we just say f without the of x attached to it, so don't let that freak you out. It's just, function notation. That's all we mean. We're going to have some equation that represents a function. Alright, so anyway, b, describe the transformations that take one function to another one, that actually the g is going to be the one that we're going to be given. Then we're going to sketch a graph and then use the function notation to write g in terms of f, and that's probably going to be a little bit weird, but let's get going. Okay, so here's what these problems are going to look like. You're going to be given a function g, and it's going to be, something with a little bit of, well, let's just call it decoration, some other numbers kind of tucked into it somehow. Okay, of course those numbers indicate some sort of transformation of some sort, and basically that's what these various parts are going to ask you to kind of describe as you go. Again, part A is just asking for the parent function. That basically means, hey, what function did we kind of start with before we started twisting it around and shifting it and stuff? So, well, hopefully it's pretty obvious for this one. We got those two vertical bars, so that originally, our original function f, that was the absolute value function. Okay, so our nice standard v, vertex of the origin, all that kind of stuff. Alright, so from v it says describe the transformations that took us from this original f to the new g. Well, and basically you're going to describe the various numbers that got stuck into it. Depending on your point of view here, there's either two or three things. The way the book's going to handle it, it's going to handle it like as three. What I mean by that is this -2 you might think is two separate things like the book does, or you might think of it as all compressed into one. But again, the book's going to do it as two, and so basically here's how it's going to play out. Okay, first of all, I'm just going to take it from left to right, and here we go. The negative, it means that we're going to be reflected. Okay, I know I've said flipped in class and a lot of stuff like that, but anyway, here we go. It's reflected over the x-axis, because normally instead of the absolute value going up, this one's going to kind of head down. So it's reflected over the x-axis. Okay, the book's actually going to write the reflections last. I think it makes more sense to write them first, but I'm not going to be picky about the order you write them in. Alright, the 2 right there means that we've been stretched vertically by a factor of 2. So, and I'm not going to be picky about the wording as long as you get your point across. You can say it rises twice as fast or falls twice as fast technically in this case, but whatever. Okay, as long as you can make some kind of sense out of the wording, I will be happy with that. Alright, and then we got this +4 in here. Now remember, that's a horizontal shift, but he's lying to you because he's on the inside. He's the secret agent. Dun, dun, dun. Okay, so basically what that means is now we're going to be shifted. Okay, and again, it looks like a plus, so it looks like it's right, but he's lying to you, so he's actually shifted left 4. And there you go. Again, I'm not going to care about the order you write these in. Like I said, the book puts the reflections last, but I think it makes more sense to put them first, because if you think about it, let's say we were reflected, well, shifted up or something like that, and then reflected. Technically, at least to my mind, that means if I'm up here and then get reflected, that means I'm reflected over the x, I'm reflected all the way down somewhere around there. So I think it makes more sense to do the reflection first, because then all you're doing is flipping it over, which is really the intent. Alright, but moving along. C, we're asked to graph it. And so basically you're just translating the stuff you wrote in B onto the graph based on the original function, what f was. And so here we go. So we're reflected upside down, but before we can really take care of that, I think we have to take care of the left 4. 1, 2, 3, 4. So there's our new vertex. And again, now it's going down, but it's going down with a vertical stretching of 2. And so that translates basically to a slope for the absolute value. So instead of down 1 over 1, we're going to go down 2 over 1. And down 2 over 1, you can do that all day. 5 points is good enough. Of course, if you give me more than 5 points, I'm not going to argue with you. But get yourself your nice V shape, get enough dots to get the point across, and then you can draw your best lines through there. Well, I guess technically those are raised, but let's not split hairs here. Alright, then moving on for D. D, this is the one part that's going to be a little bit unusual, I think, for some of you. Basically what we want to do is we want to write G as some sort of manipulation of f using the function notation. So basically our final answer, this is not what it is yet. But g of x is going to be something that's got f in it, but kind of ish, because we're going to mess with it. And yes, I wanted to do that on purpose, just write the word fish. Alright, but anyway, here's what the final answer is actually going to look like. We've got g of x. Okay, now again, I want to write this in terms of the function absolute value of x, but I'm going to use this f of x notation. Alright, well, it's actually easier than it sounds, maybe, because really this negative 2 is going to go in front of what the original function was. Granted, there's some other stuff there, but the negative 2 is going to get tucked inside of the absolute, or not inside, but in front of the absolute value symbols. So basically that's what I'm going to do here, put the negative 2 down, and then again, that's where the original function starts. So instead of writing absolute value symbols, I'm going to start the f of x. Okay, notice I didn't close it yet, because now inside, instead of the x, we've got this x plus 4. So that's going to go inside where the x is, and I'm just going to do that exact same thing with the function notation. Instead of just simply putting an x there, I put in additionally that plus 4. And then that's where the parentheses closes. And basically now that is the function g written as some kind of a combination, manipulation of the function f using function notation. And so that is, I guess, our final answer to part D. And hopefully that made a little bit of sense, but we'll do one more of those just to make sure we got the hang of it. Okay, so next example. Hopefully this one will go a little quicker, but here we go. So g of x equals this guy, and again, our parent function, f, and again, the big dead giveaway here, we got this little square. So our parent function is our parabola, but of course we're going to kind of manipulate this guy around a little bit. Alright, so B are manipulations, or transformations, whatever you want to call it. Okay, now there's no reflection in this one, so we don't have to worry about that, and there's no vertical stretching either. So basically we just have two shifts. Okay, so we're going to shift, and again, the guy on the inside, I'll talk about the 5 first. He's on the inside, so he's lying, so this is actually going to shift right 5. And then additionally, I've got that minus 6 out there, so this is now a shift. Remember, he's telling you the truth, so now it's down 6. Okay, so now we've got those. Again, I got my parabola, and again, the 1, 3, 5 is going to be kind of what I'm going to start with, but I'm going to shift right 5 and down 6, so basically that gives us a vertex. So 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6. Alright, we got that. And again, there's no manipulation as far as my vertical or flipping over, so I can still just keep my 1, 3, 5s. So 1, 3, and then 1, 2, 3, 4, 5. Got that. Again, I do have room for the 7, but I'm not going to bother because, again, I think once you have this many points, that's a pretty darn good version of the graph. So there we go. Kind of just connect the dots as best you can on either side. A little wobbly, but I think we'll get over it. Alright, and then D again, I want to just kind of write this in terms of f, so now I actually will write my final answer first. So g of x, okay, again, nothing happened in front of the x squared, so I'm not going to write anything before I start writing my function notation. But what I did is I put a minus 5 inside the x, so again I can just put it inside the function notation the same exact way, f minus 5. Again, and I don't have to put the square on there because that's what the f implies, that I've got my squaring function, my parabola, if you will. And then again, I get this minus 6 on the outside, so unlike the last one where I stopped right there, I do have this other shift, so I got the minus 6 out there. And that's what our function is, again, f manipulated to give us g. Okay, so now here we're going to start to take a look at basically what the third chunk of the homework is. Write an equation with a function that is based on the given characteristics. And this one is kind of what we did in the last set, but it's given a little bit different wording, so I don't want you to freak out when you get to it. Alright, so basically we're asked to be writing an equation in the shape of f of x equals x to the third, so here's our barrel of monkeys graph, but shifted up 2 units and reflected in the x-axis. Okay, so that's the wording I'm going to use. Reflecting in the x-axis just means we're flipped over, and then shifted up 2 units. Now there's one thing that the book does that I think is technically wrong. Their answers are f of x equals whatever here. Now if you're starting and this is f, I can't say f of x is something else, because then f of x is 2 different things in the same problem, and that just doesn't make sense. So basically what I'm going to do is my answer is I'm going to write it as g of x instead, because I just think that doesn't contradict itself like writing it as f would. Okay, so anyway, so g of x equals, okay, now we're not going to use the function notation here, we're writing the actual equation, if you will, especially because of what the book did. If they wrote f of x equals f of x with some other stuff on it, that would make even less sense than what they did. So anyway, I want something that's x to the third, but shifted up 2 and reflected in the x. Well, if I'm going to reflect this guy in the x, it's flipping it over, so I need to put a negative in front of the characteristic thing that makes it the function, so that's going to be our x to the third. Okay, I could just write the x to the third here because there's no horizontal shift, so I didn't need to make a quantity. Okay, and then shifted up 2 just makes me put a plus 2 right there. And basically it's as simple as that. Okay, now this takes me to what the first chunk of problems I'm going to assign from the homework. It's actually kind of the second piece of problems in the book. But anyway, we're going to use the graph of f to sketch each graph. I'm actually stealing number 6 out of the book here. So they're going to give you something like this. This one looks like a very piecewise functiony sort of guy. They labeled it f just to make it all nice and pretty. And then basically they're going to ask you to do 7 different versions of this graph based on various transformations and stuff that they slip into it. Okay, so starting with the first one, I've got f of negative x. Okay, that negative, of course, because we've seen that before, not a lot though. Like if I give you f of x equals square root of negative x, okay, well that negative flipped us over in the y direction. So basically for this graph, instead of going off to the right like this, we'd flip it around and make it off to the left. Okay, so that's what this negative sign is going to do for us. Everything that would be to the right, we send to the left, and actually it's going to be vice versa. Okay, again, this isn't really part of the problem, so let's kind of scribble him out. But this negative sign here makes us kind of reverse our x's and keeps our y's. So basically how this is going to play out, and I'm going to do this right on top of itself here. Hopefully that makes sense and doesn't make it too nasty to look at, but here we go. So instead of going negative 4, 2, again, I want to flip my left and my right around. So instead of negative 4, 2, I want to reflect it in the y, so now it would be positive 4. And up 2 to get a new point for our new variation of the function. Okay, and then just kind of working from my left to my right, translating the points as I go, the ones that are like dots. You could do this with other ones that you can kind of get the coordinates on if you wanted to, but I'm just going to stick to these nice ones here. So instead of negative 2, negative 2, again, I want to go to the right 2, but I'm going to maintain my y and go down 2. Okay, this one, well, 0, negative 2, well, if I flip 0 around, I still land on 0, so not real exciting there. But then if I do the 6, 2, that sends me to negative 6, 2, and gets it right there. Okay, one thing I didn't do yet that you might want to do as you do these is connect the points as you find them. I'm pretty good at visualizing this stuff, so I usually kind of wait till the end and just draw one big thing through, but if you have a little trouble with that, then maybe you want to kind of connect them as you go so you know the order to connect them in once you've got them all plotted. Okay, but anyway, started with this one, went to this guy's second, pretend to actually hit that dot, and came over here, and then we got some kind of a diagonal line going up to there. So this blue is our new version of that on top of the black one. Maybe that's not real easy to see. If that's the point, yeah, that's true, then I apologize, but I just kind of wanted to play compare and contrast with it. Okay, part B, moving on, just has f of x plus 4. Okay, and again, this plus 4, this is a little more obvious to what we've done in the past. That's just up 4. So basically I just take all these guys and go up 4 from wherever they are. So negative 4, 2 goes up 4 to get us to 6. Okay, negative 2 shifts up 4, lands me on positive 2. Same thing here, lands on positive 2, and this 2 also goes up to 6 like the extreme left end of my graph did. So again, I get something like this, and there you go. That's f of x plus 4. Okay, now if we're looking at this guy, we have a 2 in the front, so again, that's just our vertical stretching. And effectively what that does is it multiplies all our y coordinates by 2. Okay, so over here I've got negative 4 that I put in, but the resulting y is going to be twice as big because of that 2. So instead of putting in negative 4 and getting positive 2, I'll now get positive 4 out of the deal. Okay, now notice this is a stretch and not a shift, so I'm not going to move this guy up 2 as well, but if I get negative 2 as my y by plugging in negative 2 for my x, well again I'll get twice as big of an answer, so now that's actually going to give me negative 4. Okay, again I plug in 0 into my function, whatever that function happens to be, and instead of generating negative 2, I get twice as big as negative 2, which is also negative 4. And then again back over here, as I plug in 6, instead of getting that 2, I multiplied it by 2 because of that coefficient of 2 in the front. And so I basically get that graph. Wow, that was sloppy. And I get a, well, okay, hopefully with straight edge you could do that a little bit better than what I just did, but that's the idea. Okay, now with this one, we've got a double transformation going on. We've got a negative in front, which again is going to be a vertical flipping, if you will. And then we got this -4, which again is going to be a line view, so that'll be a shift to the right. So we want to take care of both of those things. We shift everything right and flip it over upside down. And okay, based on how this is, I think we can get away with doing them in kind of either order, but let's just kind of take it here. Alright, so I want to go right 4 with everything. So instead of going -4, 2, I'm actually going to go 0, 2, but again I want to flip it upside down, so I'm flipping it from +2, flipping it over to a -2 right there, so it lands on top of that other original point. Okay, and for the next guy, instead of -2, -2, again I want to shift right 4, so 1, 2, 3, 4 takes me to +2, but again I want to flip them over, so my y-coordinate of -2 flips over to be a y-coordinate of +2. And again, for those of you who want to connect the dots as you go, that's maybe a good idea, and there you go. Okay, the next dot, which unfortunately I did cover already, but our 0, -2, again I got to shift right 4, so I'm at 4, flipping the -2 to +2 lands me right there. And again, there you go, connecting the dots. And then lastly, we've got this 6, -2, sending him to the right lands me on 10. I'm sorry, I think I said negative right there, but he's +2, we need to flip him down to -2. Probably my brain was ahead of my mouth there. And again, now we just connect the dots. So there we got our new graph transformed twice, and there's the result. Okay, now parts E, F, and G. Basically the E, we've got a -3, which is just down 3, and I think we did one like that, so I'm just going to skip it. The one we just did is very similar to this one. I'm going to flip it upside down, and I'm also going to shift it down 1, and I think you can probably handle that without me talking through it. I want to handle this one and stress it a little bit because that 2 on the inside. Now we've never done that before. So, you know, if I've got y equals 2x squared or something like that, I'm trying to slip a 2 inside of there. That's, you know, a shift that we haven't done, or, you know, a manipulation that we haven't done. So basically what's going to happen here is, well, the x that you're going to get, we're going to multiply by 2 before calculating the y, basically is what that's saying to us. And so as we know, the x's are big fat liars, or at least anything in with the x is a big fat liar. And so the way it translates is that since I'm multiplying this x by 2, it's basically going to compress us in the x direction by a factor of 2, or by 1/2 as wide, or something like that, if you want to think of it that way. Alright, so you guys think about it this way. If I wanted to generate a 4 for y, normally I would have had to put a 2 in for x, but in this case, since I'm multiplying by 2, I only have to put it a 1. Okay, if I wanted to get a 16 for y, you know, normally I need a 4 there, but again, I'm multiplying by 2, so I'd only need to have to put a 2 in there, again, half as much. So when I have a coefficient like this, it's lying to you again. If you see multiplication here, you're actually going to divide your x's by that number, and if you see a division or something like that, you're going to have to multiply your x's by that number to be able to generate the same y value that you were supposed to get otherwise. So basically here is it's a compression in the x-axis by a factor of 2. Or again, if you want to think of that as 1/2, whatever you're going to do is you're going to cut the x's in half effectively to get your new graph. So instead of -4, 2, I'm just going to go -2, 2. Because again, by plugging in -2, it would have generated that or other original value. Okay, and I'm going to stop babbling about that. Okay, now the -2, -2 only has me go -1, -2. And the very convenient 0 stays as a 0. And then instead of going all the way to 6, I only have to go to 3 as my x value to generate that same y value. So again, we get kind of just a smushed version of this guy. So connecting my dots again. So this is the graph generated by putting a 2 inside with the x instead of just sticking with the original function. Okay, and here's your assignment. Okay, it is a little bit all over because, again, I honestly just didn't want to say like 5 through 74 odds or something like that, because I think some of those problems in the section are a little iffy as far as what we actually need to do. But notice a little asterisk down here on number 49. That one's got something that's a little bit tricky to it. Basically, trusting you to work through it, take a look at the answer in the back of the book. If you figure it out, great, and if you don't figure it out, call me over or talk to some buddies and kind of get how that works. But there it is. Thanks a lot. See you guys in class.